Good afternoon, good evening, good morning, depending which part of the world you live in. I know it's been a bit of a long day already. It's pretty much the end of, well, the last talk of the day. So, just bear with me for a little while. Hopefully I don't bore you guys too much. And yeah, hopefully we'll, have a bit of fun, have a bit of nice discussion at the end of it. Yeah, so my name's Navin. I'm a software engineer. And today we're going to talk about cross-site replication with JBoss Data Grid, or JDG. Right, so who am I? Yeah, so I'm a software engineer. I'm currently working on EAP, and basically I'm in the sustaining engineering team. Our primary, focus really is to be working on like stable re-releases of EAP 6, EAP 5. So just to give you an example, like just last week we rolled out a version EAP 624 because 623 had some issues, customers had a few requests, there were some other bugs, so we had to add in some bug fixes, add in a couple of little features to give the customers what they want. I've been working with Red Hat. I've been involved in open source since 2008, so it's just about 6 years now. Time flies, I suppose. Okay, so what are we going to be talking about today? We're going to go through a little introduction to JBoss Data Grid, how we can use it. We'll talk about cross-site replication, what it is, why it's useful, how can it be applied in the real world. Yeah, then we're going to go through a little demo. I'll explain to you a little bit about the setup and what we do. Then we're going to go over the sort of pitfalls and a couple of problems about it. And yeah, hopefully from there we can draw some conclusions as to what the way forward is. Before I do proceed, actually, just a couple of points. Firstly, sorry, excuse me. If the font is too small, or if you can't hear me or anything, just point it out. I've got another machine here by my side, so I can see the chat. So yeah, just let me know. Secondly, many thanks go to Tristan Tarrant, who basically successfully presented pretty much this topic at Summit, and with a bit of his help, I managed to get into Tech Exchange to talk about it again, because I'm aware that not everyone made it out to Summit, so it's a pretty useful thing to be talking about, I think. And yeah, so thanks go to Tristan. So what is JBoss Data Grid? It's a distributed storage engine, so you can use it as a distributed cache on top of your database to give you performance over there. It can also work as a primary source of storage in memory, so you can store your data in memory on disk depending on what your problem is. It's highly available, so if one of your nodes fails, if there's a problem with it, a network failure, for example, your data within that cluster is not lost. It's still available. It's elastic, so it means you can scale out dynamically, easily. You add in a new node into the cluster, it's still okay. You don't need to drop down your application. There's not a lot of overhead really in terms of adding or removing nodes that way. Okay, so just a bit of an overview as to some of the architecture, and so JBoss Data Grid comes in sort of two flavors really. You can run it in library mode, which it's just a jar file that you would package in your web app that can run on your JBoss AS or EAP, but also it can run in its own client server mode, and we're going to sort of see a little bit of that in action later on in the demo. And yeah, so I don't know if you guys can see the words here, but if you can see my mouse pointer, basically you can have remote applications that are written in sort of different languages, whether it's C++, .NET, or Java. Um, and they use a specific protocol, which I'll discuss in the next slide, to talk to your cluster. And using that, you can perform operations. And basically, you can either just perform simple map operations, or depending on what client you're using, you can basically get more information like the size of your cluster. Also, basically just get more information as to what your cluster looks like, what your data center looks like, how many nodes are there, whether a node sort of dies, whether another one comes up, and you can also control that depending on what type of client you're using. Just to point out, so if you can see the transport layer, that's basically sort of JGroups, which is just a library for like nodes to communicate and send messages to each other. And JGroups is basically the transport that Infinispan uses, or JBoss Data Grid uses, in order to allow some of the nodes to communicate with each other. Like JGroups it's a pretty mature project. It's been around since 1998. I know that Bella, the lead for JGroups, basically did it for his PhD project way back when. Yeah, and it's been in development ever since. So it's a very mature project, very, very robust. Excuse me. Okay, so about the remote endpoints. So yeah, there are three endpoints, or three types that are available. The one is memcache, which is a drop-in replacement for a memcache node, really. So Infinispan just acts as a memcache node, and you can sort of perform your map operations with Infinispan as you would memcache. There is a REST endpoint as well. So you just assume you're just talking to another RESTful server. You can perform your regular CRUD operations over REST as well. Then we get on to Hot Rod. So Hot Rod is a binary protocol which has been developed by the Infinispan team, and it's optimized for accessing distributed data. And also, Hot Rod is where there are specific clients for it that are available as well. I know that the Java, C++, and C# clients are supported. These are the sort of more robust clients that give you, information or topology information about your cluster, what's happening, where the nodes are being, added or removed. There is a Python client as well, for example. There's also a Ruby client. But those ones are relatively simple in a sense that you can just perform your basic map operations on them, and they're not part of the supported product as far as I'm aware. And also, yes, it's important to note that all three endpoints can read or write to the same cache. So within one JVM, you can have your memcache endpoint, your REST endpoint, and Hot Rod endpoint all running, and they can talk to the same cache and perform the same operations on the same cache. Okay, so a little bit more sort of information or housekeeping on the generic blob that is JBoss Data Grid and what it can do. Yeah, so it can act as a high performance persistence layer as well. So basically, you just add it on top of your database, and basically it can then, I know it can persist to various types of cache stores, or I mean, those cache stores can be on disk, but they can be elsewhere as well. And there are specific types that ship with JDG as supported. I know that, for example, there is a MongoDB one, but that's an external community project. So, I mean, there are quite a few around, but not all are supported. There is the querying feature as well, which is, well, basically you run a full text search on your data based on the values that you're storing, as opposed to your keys. It's not like you're just performing a get on a specific key. You want that, trying to get that specific value. So the querying uses Hibernate search and Apache Lucene as well. So I know that Apache Lucene has, I mean, that's got an Infinispan extension. So Lucene is the indexing library that's used by Hibernate Search in order to optimize the querying. So, what Lucene can do as well is put its indexes in a separate Infinispan or JDG cache, as well as querying the actual data that's in a separate cache. I mean, they will exist in the same node, yes, but they are separate caches and managed separately, so that data doesn't necessarily interact. Also, an important thing is the monitoring and management. At the end of the day, whichever applications are running, you still need to be able to look around and see what's going on. You can look at your JVM sizes, how much memory is actually being used, and it's very useful for fine-tuning high-performance applications. I mean, it's pretty obvious that if you can't really find out what's going on, it's going to be kind of difficult to optimize things. So yeah, it's pretty important on that. Final sort of point on JDG use cases as well. So as I said, it can act as a distributed cache where it just persists to a database, and where you need that speed improvement. So basically, as a client, you're just performing operations to something in memory, and then you let JDG figure out what needs to go to the database and what needs to stay in memory. Also, it can be used as a distributed data grid, and that is where you use it as a primary data store, so you don't worry about your persistence, storing things to disk. And yeah, the prime feature for that is really if you have, or the prime use for that is if you have unstructured data. So you can't really use a conventional database to hold your information. Okay, changing gears a little bit now, and we're on to cross-site replication. So I'm pretty sure that most people have heard of this feature before, or heard of this term before. Cross-site replication or data center replication. I mean, these two terms I will probably use interchangeably, so just be aware that they're the same thing. Yeah, so the term basically means we're just moving data from one data center to another. And we're going to talk about why it's useful and why people use it in the real world. So first point as to why it's useful. So you might need it to recover data that's lost or that would otherwise be lost. I mean, imagine there's some, like a natural disaster, an earthquake hits or something, and you lose your data center. If you've already backed it up to another location somewhere else, particularly if this is critical data for your business, for your work, yeah, you're still okay because the stuff is still available somewhere. There could be issues of network failure where rat eats cable, for example, and all of a sudden your cluster is dead. There are all kinds of reasons for recovery. I mean, it's interesting story actually. I was told of this one example, and I digress here a little bit. this one example where I think there was this one bank that wanted to store a lot of its critical data in a different data center. But what happened was they were actually, the other data center was just across the street from its main one, and they were running a wire underneath the road, which sort of joined, which was between these two buildings. True enough, at some point, I think there was like a subway being built, or the road was being reconstructed. Some drillers came in, cut the cable, and then both data centers lost connection, which I suppose in hindsight meant it's probably not the smartest thing to have your backup data center across the street. But yeah, it's still important to do that, so your stuff is still alive. And yeah, so point number 2, like, is just to follow the sun. It's a method or a policy that a lot of people do in terms of, I mean, particularly in this world of cloud computing and having data remotely. It's kind of important to keep your data fairly close to where people are actually going to use it, because the further away it is, the longer your ping times are, and the longer it takes to get hold of your data. So it's important to keep your data close to clients, and as a result, that'll mean moving it from one data center to another. So you need to be able to move this stuff around. And yeah, so also it means not all of your data centers are active at a given point in time. So it's important to be able to move this stuff around efficiently. David, can cross-site be Amazon EC2 Singapore with EC2 Europe? With Infinispan, yes, that should be, because what we are going to show later on here is basically as long as one node in Singapore cluster can talk to EC2 cluster, you will be able to replicate. But hopefully, when I get to that in the next couple of slides, you'll have an answer to that question. Is that all right? No worries, man. Part 1 to answering your question, David. Okay, so here's how the replication works. As I had explained earlier, or if you do remember the initial diagram I showed you early on, was that JGroups transport is basically what allows you to move data from one node to the other. And basically what we're doing here is we're just saying that there's an additional transport that connects one site to another. Each site will have a designated node, or the master node, which will talk to the other master nodes in the other sites, or in the other data centers. I mean, the example we're going to go through later basically just uses 2 clusters, but in reality, you might well have several more clusters, and then that way each designated node will talk to the other one. But just a point of note that the replication only happens after the local changes are committed. So once we know in like whichever data center we're trying to put our data in, for example, with new object, new person has joined company, we want to add to our big blob of data. Once it's in the data grid or in the distributed cache, only at that point will we replicate to a different data center. And well, pictures speak 1,000 words, right? So here's something I quickly drew up together. So imagine each pink blob is this massive data center somewhere in the world, and pink blob number 2 is somewhere else in the world. There would be several slaves or several other nodes but each master will talk to each other over the cross-site transport. So as long as these two masters can see each other, that's not a problem, and we're all fine and dandy. Just a note on some of the configurations for cross-site replication and how you can do it. Do the masters have fixed IPs, or is there a discovery mechanism? I believe like for the actual masters, they have fixed IPs. The discovery mechanism is within the cluster. Because if you think about it, another master could pop up anywhere in the world, really, right? You need to tell one master really where this other master is likely to be, because at least within the same cluster, they're all on the same network, so they'll be able to discover each other easier. So asynchronous, the replication modes, there are two of them. That's pretty straightforward, synchronous and async. So for sync, we'll wait for the op to complete locally and remotely, and only at that point do we return. For async, the local ops will return immediately, because that operation is quite fast, and then the remote ops will be put onto a queue and be processed separately. But I mean, this is all very lovely, but things can still fail, right? It's a very cool feature, sure, but there might still be issues, and yeah, so the replication could still fail. It's a big cable underneath the sea if you're replicating from New York to London, for example. So what are we going to do if it fails? There are configurable policies where we fail that put operation, or we just warn saying, hey, guess what? There's a problem with the replication, or we could just say, you know what? I don't really care. I don't really care if it's failed. I'm just going to ignore it. Or whatever other custom policy we might want to build into it, whether it's for retries or whether it's for something else. Okay, so time to talk about the demo first before we dive into it. Just to point out really what we're going to do, where we've got two sites in the demo. One is the Earth, one is the Moon. I mean, just to show that JDG is so cool, we can even replicate over planetary bodies, not just within the Earth, and we are that awesome. We're going to have 2 nodes per site and 2 caches per site. So one site, there's one cache which is just like local clustering. Then the other one's going to have local clustering and remote replication. So what we're going to do really is we're going to put in some data into the Earth, and we're going to see it come up on the Moon immediately. I mean, okay, it would be lovely if we could replicate between EC2 on Earth and EC2 on the Moon, but unfortunately, Amazon don't have EC2 on the Moon yet. So what we're going to do is I've set up the environment locally to mimic the situation where I've got 2 clusters running, and then from a web app, I'm going to try and add some stuff in. 2015, yeah, hopefully. Hopefully it is in 2015, David. Okay, so I'm just going to hop into the terminal. Let's see. Has it quite come up yet? Right, I mean, anyway, so as you can see, I've got like a bunch of tabs open in the terminal. Hope you should just about make out that there are 5 different tabs. So the first 2 are the 2 nodes on Earth. The next two are two nodes on the moon. And the last one is basically my just vanilla JBoss EAP running, which has the web app deployed. And what we're going to do is we're going to go put a bunch of stuff on the Earth, and then we're going to blow it up. Imagine like the sun goes supernova, but somehow the moon survives. So we're going to make sure that that our data is still there on the moon. And we go. Lovely. It's still got my data from my trial run. But anyway, basically the way it works is I double click on this little node on Earth. I create just like a little colored widget. It's, I mean, it's fairly simple really. All we're trying to demonstrate is the replication and not anything else really. And yeah, I just add that, bang, and I see it come up on the moon as well. So just so you guys know that those orangey boxes was not me being cheeky and putting the stuff there before everybody logged on. You saw it happen live. Just as a side note regarding the code for this demo, it is up on GitHub at the minute. I will speak to Tristan to figure out what we want to do with it, and it needs to be documented. So we'll go ahead, document that a little bit more, and then we can potentially open it up for use. However, if not, or if anyone wants to talk about the demo or reuse it, then by all means get in touch with me. But yeah, so let's go on and create the third widget just because, and because 3 is a lucky number, something greenish. Right, and as you see, it comes up on the moon instantly. So this has been set up to be a synchronous replication. So once it's done locally, we'll go and perform once we complete the put locally, we'll go and perform the replication remotely. Once that returns, bang, it gets displayed over here. I don't know if you guys can sort of see the difference, but it's bang on over here. Okay, so time for some nasty hurricane to go and destroy the Earth, or whichever was it meteor that killed the dinosaurs? Some sort of disaster like that. So yes, I've destroyed the servers on the Earth, as you can see. Servers are destroyed. Right? Now, and over here as well, back in the web app, the Earth is all redded out. That means it's gone. The cluster is dead. The data center is down for one reason or the other, but the stuff on the moon is still alive. Now, there are other sort of configurations as to, or there is other documentation as to what's going to happen when sites come back up again. So I mean that's pretty nicely detailed up, and if there are any questions, I'll point you over to that. And yeah, so that's basically what's happening over here. We've seen just a simple use of cross-site replication, and it is actually relatively simple to configure and to build together. I mean there were some other pitfalls with setting up this demo, but again once the code sort of goes back up on GitHub and is nicely documented, you guys can go ahead and use it, I'm sure. Right. So just to hop back in here, now that we've seen that cross-site REPL actually working, we're just going to discuss some of the limitations about it. I mean, this is these are some of the things. I mean, these limitations we can't really show in a remote demo so well, but it's something just to talk about and be aware of. Yeah, so one of the problems is the initial state transfer. So, when a backup comes alive, it takes quite a while to move the state around, to move your data around. So yeah, it just takes time, and that's a little bit of a problem. Synchronous transactions are slow. You've got to wait for all these operations to complete before you can return back to your application, or return back to your client, depending what setup you're using. At the minute, async stuff is unreliable, so we can't really use that yet. But yeah, so what's in the works? Is cross-site state transfer. So basically, the goal for this, what are we trying to achieve here? We're trying to sync new and previously offline sites. Depending on where what the application is. Sorry, because using the follow the sun example, some sites are offline for a period of time. They will come up again when it's early morning local time. So that's these sites need to have the data pushed to it, and ideally we'd want to have management operations or be able to tell the servers when to replicate, when not to replicate. Again, that's depending on what conditions are there at the time. We'd want to be able to do this concurrently with other operations. So for example, the data center that we are replicating from, we don't want to block other potential operations coming in, because people might still need to access that data. Think about it. Imagine like YouTube are moving all their videos from one data center to another, and someone's trying to watch watch Gangnam Style again, and they can't access it because this stuff is all blocked up. It's not ideal, right? So it needs to happen concurrently, and it needs to be non-blocking as well. So yeah, like just to bring up some conclusions to discuss about this. What we want to do is to stabilize asynchronous operations, because that's where we can gain quite a bit of performance. The reason being is that if you're going over big geographical distances, there's quite a bit of latency, right? So sometimes if you're experiencing like 1 second pings or 1500 millisecond pings, it takes a long time to move all this data across, and that's quite a big performance loss. So we need the async to be stable. We need to be able to work with this stuff. So, and also it's just that sometimes if we've got a larger cluster, it can mean it's a bit more fragile. More wires means you're more likely to have a network failure just by law of averages. So yeah, we need to be able to do this stuff in the background, and it needs to happen fast as well. So yeah, what is the solution from here? Well, the solution is we need to have, like Infinispan or JDG needs to have reliable asynchronous clustering. And I know that there are people working on that, and that is the plan over the next few months, or well, yeah, at least the next few months, where people are looking into that and people are trying to make that viable. And yeah, from there on, it's hopefully we'll get it done over the next little while. Right. So, I mean, that more or less wraps everything up in terms of what I wanted to say. Um, if you ever want to get in touch, um, the Infinispan guys are on IRC Freenode. I know some people in the field don't like that so much, but that's where all the discussions happen. The guys are very open source, in just in the generic ethos. For example, they have their weekly meetings on IRC. So if you want to find out what's going on, like Monday lunchtimes or so European time, or Monday afternoons European time, all these guys will sit down and discuss what they've done in the previous week, what their problems are, what they're working on a very public chat channel, so everybody can see what these guys are doing. And personally, like, I know that they're a really good team. They're always very personable. You can always talk to them. They'll always help you out with problems as well. So, if you do have any questions, feel free to ask up on there. If you want to add up blogs to your RSS feeds or anything like that, there is the Blogspot account, and over there you find information on new releases. You'll find information on like performance improvements, what's happening with new features, all kinds of stuff. So for example, Infinispan 7 just had an alpha release at the end of last week, and there's already a blog with lots of graphs showing you the performance improvements. So that way, if there are any other number crunchers out there, you can look at that and get some useful stuff from there. Yeah, then there are the Twitter links at Infinispan, or you can find me at Navin Surtani if you ever want to have a chat. I'm generally, well, pretty much always on my phone, so I'll be able to be in touch. And yeah, that's pretty much it from me. I'm just gonna open up for Q&A now. If anybody else has anything to ask. I realize that, well, I mean, it's a little bit short in terms of time, but I know that well, it's been a long day, so didn't want to overload too much. Yeah, David, I'll work on that. In fact, I'm making a note right now. Get GitHub repo up soon. I'm assuming that everyone here is on. It can be hard to demo, but hopefully you guys took away something from it. But anyway, I'll get the GitHub repo up, and I'll be sure to document it so people will be able to run it themselves. Also, if you have any other suggestions for the demo, feel free to get back in touch. I'm assuming that everyone is on APAC tech list, and I'll send out the link for that once it's done as well. Sure, David. Don't apologize for questions. Auto scaling on my mind. Do you need to restart servers to add master nodes? Good question. I would think so. Because of how the configuration works, you need to start it up saying, hey, you are a master node. But actually, no. Good question. I'll check up on that. And yeah, I think you might be right, Christina. But anyway, I will check up on that and get back to you. Okay. Thanks a lot, guys.